Hey, today let's talk about doing a pressure dependent VAV system from scratch in Johnson Controls. I know last week we did a complete VVT system with a unitary controller that controlled a few zones. But what if you just want to use the VAV controller and as a pressure dependent device on a network somewhere or even not off on a network? I'll show you how to do this from scratch. So let's go up here and do file new, and let's call it PDVV. And then we're just going to do custom applications here. And I'm not going to select anything from the list. I'd rather just add it all from myself. So right here we have a blank canvas. First off, we're going to come up here and define our controller. And let's just say we're using the CVM3050. And then we'll go ahead and add a network stat. It's going to be a network NS8000 sensor, set point, temperature, me, done. Okay, so that gets us to a starting level here. Let's go network inputs. I know we're going to need an occupancy aux schedule. So let's go ahead and add one of those and change our enumeration to an aux schedule. And for a VVT system, we need some min and max settings for cooling and heating. You never want to go into zero unless you're unoccupied. The building's occupied. ASHRAE guidelines say you have to have so much flow. So let's just set some cooling minimums. Cooling min, do cooling max. This is damper position. And by setting it here, it makes it easier to change, and you can bring these points in to a JCI. Let's go ahead and do this for heating as well. And I'll go ahead and have a heating max too, just to make it easier. All right, and so let's go for the cooling min. I'm gonna do 10%. For the cooling max, let's say they oversize this box and really we don't want to go above 90%. And for the heating min, let's say 15%, just to give it a different number. Again, these will be set by you or tab or whatever the customer comes up with. And for heating, say they don't really want to get above 60% open. Okay, so we got that. So let's see, we need a zone temp determination to give us our effective heating and cooling set points, right? So we'll bring that guy in. And when I bring that guy in, it actually brings it in the parameters down here. See? So I'll go ahead and make that 72. Apply. On the remote set point, I'm going to do hardware. And then I'm going to go ahead and connect my occupancy. It's not going to connect there, so I'm going to do another block. But I can connect my hardware set point is going to be my zone set point. All right, and for our occupancy, we need occupancy mode. And then that's going to be the aux schedule. We're going to connect that over. Okay, and now this will connect to that occupancy mode right there. Now I brought this in just in case we put a PIR sensor in or whatever. It'll allow us to do a temporary occupancy over the aux schedule in the room. So it's good to have this. We have that. Now, you know what? Let's bring in a Boolean point for Autocal, just in case. Just in case the damper loses track or something like that. We're gonna bring that guy in. I'll show you what we'll do with that later. All right, so we have that, we have that. Obviously, we need a damper, right? So we're looking for a damper. Now let's scroll down. See, Supplier Air Damper. We want the integrated one since we're using the controller. Integrated damper. What's that? Now we can bring in, basically, we're going to make a hybrid activity block. Call it damper control. Okay. And inside that hybrid activity block, let's think about our states here. Let's make our states. I think there's a control mode here. Yeah, I want to do control mode. That'll give us heat, cool, and some stuff here. So we're gonna have an input activity block to control this with the same kind of state text here. So control mode, call this mode. All right. I know I'm jumping back, but I got to go back over here because the air handler is going to tell us what mode it's in. So we're going to do an enum, and we'll call it AHU mode. And you know, we're going to have to suck that point in, so I'll go ahead and do an underscore there, get rid of that. And I believe there is like a cooling heating out. Yeah, there we go. So it's either in cooling mode or in heating mode, right? So we have our damper control. So let's go and view the logic of that again. So in heating mode, we're going to want, we're obviously going to have an output float for our damper. For CMD. Okay. We're still in heating mode. We're going to need some inputs here. We're going to need our temperature. We're going to need our set point. We're not going to do zone set point. We're going to do effective heating set point. We're also going to need our effective cooling set point. We're going to need our min cooling. We're going to need our max cooling. I always do that wrong. We're going to do our bin heating. And our max heating. All right, I think that's all the inputs we need. So in heating mode, we're going to do a PID. We'll go ahead and do it right. Do the PID preprocessor. And the PID preprocessor is already set up for zone temp, so it's already set up good there. And then we're going to do the PID. Now, the set point, we're in heating, so we want the effective heating set point. We want the zone temp, and then we're going to go ahead and connect all of these up. And you know what? We have to set up our PID here. Since it's heating, we don't want it direct acting. We want it reverse acting. So as the temperature goes up, we want the signal to go down. And then we're going to go ahead and expose points for connection. We'll do a high limit and low limit. And that's what we need this max and min heating for. Here's the high limit is going to be the max. The low limit's going to be the min. And just to clean this up, let's get rid of these lines. Okay, one more. There we go. And we have an output there. We'll keep that line. So that's heating. Let's copy this for cooling because we want the same thing in cooling. But we do want the PID to be direct acting in cooling. As the temperature goes up, we want the damper to open more. So we got high limit is max, low limit is min. Our set point is going to be our effective cooling set point, and our process variable is going to be our temp. And then we'll go ahead and hide the lines here. Now for fan only, I'm just going to do a constant float to the damper. And that's just going to be a 0. I'm not going to change anything in here. That's just 0. So in auto, I'm going to do the same thing. Constant float, damper, and then off, same thing. Constant float damper. So that's going to close the damper on all those states right there. So now we got all our states covered. So now we have to come down here and figure out where everything's connected. I'm going to skip hit mode for right now. On zone temp, obviously that's going to go to our stat. Effective heating set point, we're going to get that from here. An effective cooling set point, we're going to get that from here. And min cooling, max cooling. Now this is an important step. Don't forget to make your connections. It's where most people kind of mess up. Min heating and max heat. That's just the percentage open that we're going to allow the box to go. And of course we want to tie that to the damper. And assign our points. all we have is a damper right now, and that's integrated, you see. Just for giggles, I'll throw a discharge air temp in there. I usually always include a discharge air temp on my box, whether it's cooling only or what. It just kind of gives me an extra point to see on the front end. It's nice for graphics. I guess it can get you in trouble if it goes out and the customer complains or whatever. But this is it. So now we just got to figure out how to control the mode there. And we're going to use the state tables for the mode. So what we'll do is come down here. And you know what? I won't, if someone actually puts this in Autocal, I don't want it to stay in Autocal. So I'm going to come over here and I'm going to do a like hybrid activity block. This one might look different. View logic. So for this one, I'm going to bring in our Autocal, which is input boolean. And then what I need is a timer. Bring out the timer. Now, when you bring out the timer, make sure the state up here is highlighted. I'm going to do a minimum on time. So I'm going to change this to pulse, minimum on, and I'm going to do 65 seconds. Okay. I know our damper stroke time is 60 seconds. So 65 should give us enough time for it to Autocal. It's going to go ahead and add this enum translation in there. We'll just make sure false is off, true is on. That's what we want. So we're good there. Now for false, we need an output boolean. Okay. And this is just our Autocal. So we need a constant. And it's going to be a constant boolean. And it's already false, so that's what we want for off. And for on, we're going to do a constant boolean. And we're going to make it true. There we go. So now we got a timer that's doing these states. That way it won't stay on forever. So now we're down here in our states tables. Let's edit. Let's see if we can't get rid of that. Get rid of that. It makes us have one on there. So we can do, we'll just want to create a table. We're going to call it awk. And it's going to be effective awk. Or it's awk effective, I believe. Awk effective. Okay. And then we need our column be damper control. And that was control mode. Now that we have that, we can delete that column. We can delete that table, and we're there. So now we want to add another table. I'm going to call it Autocal. And that was a boolean. And then we finally want our last table to be HE mode. And I believe that one was cooling, heating. Alt. Okay. Now, let's see. In unoccupied mode, we want that to go off. In Autocal mode, if it goes in Autocal, we'll go ahead and turn it off. We could turn it either any one of those. In heat cooling, we want to go cool. In heat, we want to go heat. Apply. Back up here. Now our connections, we should be able to connect our mode up to the state tables, which we did. We should be able to come over here to this Autocal. First, we're going to connect it to our network input, and then we're going to connect it to the state tables for Autocal. Okay, that worked. And then occupancy. There we go. All right. So now we're all set up. This should work. So let's go ahead and simulate it and make sure it all works. So if we simulate it, we'll start in cooling mode. Start simulation. All right, we got simulated going. We're in cooling mode. Our damper's at 10%, which is our minimum. So that's what we want to see. Excuse me, our zone temp is at 72. And our effective cooling is at 73. So let's change our set point here. We'll put it down to 70. Now our effective cooling went down to 71. Our zone temp 72. So we should see an increase in our zone damper command. This PID's a fairly slow PID, but that's what we want for room temp, because room temp changes slowly. As you see, it's starting to climb. Now that's going to go all the way up to whatever we set our cooling max for, which is 90. Not going to bore you with that. Just know that that's going to go there. And let's just throw it in Autocal mode to make sure it goes to 0 for 65 seconds. So if we send this to true, even when we turn it back to false, it's going to stay true for that 65-second time frame. That gives the controller enough time to go all the way down to 0 and reset itself. And if we look at the states tables, we could see that that's untrue. Oh, we didn't connect our AHU mode. So we're always going to be in cooling there. So actually, I'm going to stop simulation. We went out of Autocal mode, if you see. Our damper went that way. That's the one thing I forgot to connect. And I knew that because this is orange. When this is orange, that means it's not connected to anything. So how we connect it is we come up here to AHU mode, go to connections, right click. Here's our state tables. Boom. Now we're connected. Now we can simulate that again. Start simulation. This time we'll put it in heating mode to make sure that works. We should start at, I believe we did 15%. Now, as you see, my simulation speed, I'm doing it true speed. I brought that all the way down to 1, so I'm not multiplying the speed out. If you don't change that, I believe it's 4 or 5 times the speed starting. We're in cooling mode. If we get a heating mode from the RTU, AHU, whatever, we're going to start at 15%. We can look, zone temperature is above the heating set point. So let's just lower the zone temperature. We'll say it's 68. And that should start our PID to increasing. Again, we're doing a very slow PID because room temperature doesn't change fast. There we go. The damper is opening. And that's going to go all the way up to the heating max. So we have one more thing to check out. We want to make sure the aux schedule works. So if I go unoccupied, our damper goes to 0. So everything works. So obviously you would have to adapt this if you had a fan or heating strips or a heating coil somehow. You just add that output control in here and it works out. But this is the simplest way to do a pressure dependent Johnson control VAV system. Thanks for watching.